Hello. What's up, guys? Welcome back to our May week 1. Okay, happy Wednesday to you. I assume some of you are from Honey's class, right? Just to make sure. Is it? Are some of you from Honey's class? Hi Wayin and hi Shujun. Have I seen you guys before? Have you guys been in my class before? Is this your first time or are you from Honey's class? Right, because I know that he's not around this week, which I assume some of you are from his class. Right, so guys, we are continuing with our chapter 5. Right, if you're from Honey's class, my progression is slightly different. I might be slower or I might be quicker, I don't know. Oh, first time. Is this your first class, or are you on a trial, or are you from Honey's class? What branch are you from, by the way, Wayne? Just to ask. Right, guys, last week we have finished what is your carbon compound. We have done this. Okay, as I've mentioned, what is a carbon compound? A carbon compound is any compound which contains carbon. Well, no shit. This is a stupid point, right? It's like when I'm not full, when I'm hungry, is when wait, what am I saying? Okay, when I'm hungry is when I've not eaten. No shit, right? Oh, first time, huh? What branch are you from, by the way? Which branch did you register in? Right, so we have finished our carbon cycle also. We have finished our hydrocarbon. Remember, we said this. Okay, guys, I want to pay attention to this thing, right? We have mentioned this, and I'll mention this again. What is hydrocarbon? Hydrocarbons, they are compounds which contains hydrogen and carbon. This is similarly to that stupid point just now. You see, carbon compound is a compound which contains carbon. Okay, no shit. And then hydrocarbon is a compound which contains hydrogen and carbon, which is almost the same thing, right? So who is a hydrocarbon? What is a hydrocarbon? A hydrocarbon is usually a fossil fuel, right? We have 3 types of fossil fuel. We have petroleum, we have natural gas, and we have coal. Remember this? These are all formed by dead organisms millions of years ago under years and years of pressure and heat. Remember, I asked you to highlight this point? After years and years of pressure and heat, they will turn into this black color liquid. We call it petroleum, or natural gas, or coal. These 3. Okay, so the difference is petroleum and natural gas, they are usually in the sea. Okay, that's why you see an oil rig in the middle of the sea. They will drill down for petroleum and natural gas, but coal is usually underground. Okay, they are formed on land. These are from dead land animals. These are from dead sea animals. That's the difference. Okay, that is the difference. Right, so guys, let's move on. So this fractional distillation, I've mentioned this last week. When we heat petroleum to different boiling point, we will get different stuff, right? We go from the lightest color, the cleanest, to the dirtiest. The more bottom you go, the dirtier they are, because the temperature becomes higher. As you cook your food hotter, they will become blacker, darker. Similarly here. So your petroleum has natural gas. Okay, the first box is natural gas. And then this is your cooking gas. Second is petrol, the one you put in your car. Naphtha for plastic. Kerosene for planes. Diesel for lorry and bus. Lubricating oil for your machines, like your car engine uses or your engine oil. Fuel for ships. And bitumen for your road. Right, we put bitumen on the road to make asphalt. Okay, so the more bottom you go, the darker they turn, right? Which brings me to my experiment here, guys. I'll just roughly go through this. This is very easy. As you can see, petrol, naphtha, kerosene, diesel. Okay, petrol, naphtha, kerosene, diesel. Okay, we are not messing with these because they are too dirty. So as you can see with the color, okay, let's see the boiling point. Petrol has the lowest boiling point, followed by naphtha, kerosene, and diesel. And you look at their color, you understand. Petrol is really clean, like light yellow. Naphtha, kerosene, diesel, as you go down, they become more and more yellow, more and more yellow, more and more yellow. As in diesel looks dark brown, it just looks dirty. Okay? You guys okay? You guys okay? This is actually last week's stuff, huh? This was last week's stuff. Right? So should be pretty easy. All right. So moving on. Today, our main point is this. Today, our main point is this. All right. You guys okay so far? You guys okay so far? Can you give me an okay in the chat if you're okay? Can you? Are you guys okay? Okay, cool. Cool. Just to check, just to make sure you guys are there. You guys didn't fall asleep. I know you guys are. I know this hot weather is making you really sleepy. I know I'm very sleepy too. Hi, Jella, how are you? Did you watch the video I sent you last week? Have you watched the video? Right. Gabriel, are you there? Gabriel, are you there? Sophia, are you there? Yes. Hello, Shujun, how are you? Right. So we have finished this. Okay, let's look at the main point today. Okay, last week, guys, was the easy one. Okay, today, let's look at something more technical. Right. So, guys, hydrocarbon is divided into two types. Hydrocarbon is divided into two types. We have saturated hydrocarbon and we have unsaturated hydrocarbon. In BM, this is called tepu and tak tepu. Okay, what's the meaning? Right. Guys, do you know what is saturated? When I say saturated, it means full. Okay, it means full. Right? And non-saturated, unsaturated, which means it is not full. Right, so what does it mean? Okay, guys, before I move on, there's something about carbon that you should know. There is something about carbon that you should know. For some reason, right? Carbon has 4 hands. I'll draw hands for you, right? So carbon has 4 hands. That means carbon can hold onto 4 things, right? I'll say this again. Carbon, guys, did I get disconnected? Oh my God, this happens every time. My screen just flashes and all my chat is gone. So annoying. Right, anyway, so if you missed just now, okay, let me repeat this again. Carbon, for some reason, has 4 hands, right? That means they will hold onto 4 things. They can hold onto 4 things at once. Okay, what does it mean? Okay, what does it mean? That means, okay, let's look at here. Let's look at here. Because carbon can hold 4 things, right? Don't ask me why 4. That's the way it is. Naturally, carbon can hold 4 things. Okay, and let's look at saturated hydrocarbon. Do you know why we call it saturated hydrocarbon? Because it is full. What does it mean by full? Every carbon's hand is full. What do I mean? Let's look at the first carbon. First carbon, can you see all the 4 hands are occupied? All 4 hands occupied. Second carbon, 4 hands occupied. Third carbon, 4 hands occupied. Right? So everyone is occupied here. All the carbons are occupied here. Right? That means if there's one more hydrogen here that comes and say, hey guys, can I join? Is there another place for me to sit? Is there another place? Is there somewhere that they can fit in? Can carbon still hold anything? No, right? Okay, there's nothing they can hold. So in this case, it is already full. Sorry, bro, the table is full. That's why we call it saturated hydrocarbon, because it's already full. There's nowhere else hydrogen can sit, right? And these single lines, we call them single covalent bond, right? I just usually tell my students to cut off the covalent, right? Because they're not learning chemistry. This is a chemistry word, right? Last time I used to teach chemistry, covalent is all we mentioned. But you are studying science, you don't bother with covalent. You just say single bond. They are all single bond, all single-handed. No more space for you to add. All right, this is what we call saturated hydrocarbon. All the spaces are full. Okay, everyone is full. Full. And on the other hand, right? Let's go to the other hand. Okay, on the other hand, you have unsaturated carbon. That means they are not full. Right, guys, can you see two holes here? There's two more empty space for hydrogen to sit. That means, right, this carbon, they are like, hey, I got nothing to hold, nothing to hold. So they will do, they will hold each other instead. They will hold each other instead. Wow, that sounds so gay. Right, so they have no one else to hold. They will hold each other instead. So now you see, you have the carbons holding each other with two hands. So gay. So sweet, right? So two hands, right? So this is what we call a double bond, a double covalent bond, or we just say a double bond, right? That means if there are two hydrogen says, hey guys, can we join? Yeah, sure. There's two more places here. Take a seat. Right? So this is what we call unsaturated hydrocarbon. They are not saturated. They have empty space for someone to join in. Okay. So saturated full, every seat is full. Unsaturated not full. All right. You might say, sir, so what? What does it have to do with anything? If they are saturated, so what? If they are unsaturated, so what? You won't learn this yet, but next week, when we talk about fats, we will. Guys, if you have eaten potato chips before, or anything for that matter, if you read the food labeling, have you seen this thing called saturated fat? And have you seen this thing called unsaturated fat? Right? And I don't know whether you know this. One of it is good for health, and one of it is quite bad for health. Right? This is where we apply our saturated and unsaturated, which in this week, you have no idea. We don't care about this first. You just need to know you have the full one saturated and you have the not full one unsaturated. Right? That means hydrocarbon, okay, hydrocarbon is petroleum, natural gas, and coal, right? Fossil fuel, right? Hydrocarbon is fossil fuel, right? Then if you ask me, sir, is petroleum saturated or unsaturated? Is natural gas saturated or unsaturated? Coal, is it unsaturated or saturated? They can be both, right? They can be both. And doesn't it make you sick? You keep making this word, you keep pronouncing this word. Guys, don't you think this word is so freaking unnecessary? Okay, try and say why. No why, just for a reason. Okay, so can you say unsaturated hydrocarbon really quickly for 3 times straight? Saturated hydrocarbon, saturated hydrocarbon, saturated hydrocarbon. You see, it's like a mouthful to say. Okay, so for you lazy people out there, okay, okay, because I'm quite lazy. So you see, scientists they are like, hey, every time we say this word, very tiring leh. Every time we say this word, also very tiring leh. So to make everyone's life easy, scientists just simply name saturated hydrocarbon as alkane. Right? Walao, sir, might as well just say this word earlier on, right? Because you need to know the basic, right? So this is fine, okay. While the unsaturated hydrocarbon, we just simply call it alkene. Does it make your life easier? So, right, I have students, okay, you see, this is the thing about alkane and alkene. When you say saturated and unsaturated, usually you won't get confused because you know saturated is full. And you will know unsaturated is not full. But what about alkane and alkene? Sometimes you will mix them up. You don't know which goes to where. Okay, very easy. You see alkane, alkane is an A, right? A is like A. A is A. What is A? A means one. I have a car. I have a PC. I have a girlfriend. So so you see, it's all single, it's all one. So all the line also one. So it's alkane. Alkane. In BM, it's called alkana. Okay, alkana. And then for for the non-saturated one, alkene, I just somehow think, right? I just somehow think, these two lines, it looks like an E. Okay, not really lah, but this is how my brain works, okay? Oh, it looks like an E. Okay, so it's alkene. Alkene, right? Or you can just draw your E this way. There you see, look like an E. Aya, chinchai lah, as long as you remember lah. So you have A alkane, which has 1. You have E alkene, which has 2. Okay, simple ah. Simple. So you have saturated, unsaturated, alkane, alkene. Okay, and let me tell you something. Alkane is a family because we have many alkane. Alkene is also a family because we have many alkenes. And these family, these groups, we call it homologous series. Homologous series. So alkane is a homologous series. Alkene is a homologous series, right? So you might say, sir, why got so many types of alkane one? Why got so many types of alkane one? Because the alkane with 1C, we call it methane. 2C, ethane. 3C, propane. 4C, butane. 5C, pentane. 6C, hexane. If I say you must memorize this, what are you gonna say? I'm just curious, okay? If I tell you this is a must memorize part, what will you say? Yeah, I'm just screwing with you lah. You don't need to memorize this. Yay, right? But what am I trying to show you here is, you see, alkane always has 2 hydrogen more than alkene, right? That's all you need to know, right? You see, this is C2H6. This guy is C2H4. I always have 2 more hydrogen in alkane. So C3H6, C3H8. And can I tell you something interesting? Why is 5-pentane? You know what is pent? What is hex? This is actually maths. You remember polygons? Right? Yes, pentagon. So pentane. Hexagon, hexane. So can you guess what is 7? Can you guess what is 7? What is a what is a polygon with 7 sides? Come. See if you remember. Guys, this is maths. Right? What is the polygon with 7 sides? And what is 8? What is 9? What is 10? No? No one? Right. So yes. Wow, very good. So oh, that's very good. Yes, heptane. What about 8? What is an 8-side polygon? What gon is it? What gon? What gon is it? Yes, it's octagon. Don't simply so it's an octane. Okay, octane. Guys, you know what is octane? You know what is octane? Octane is your petrol. Right? You know what is RON 95? You know what is RON 95? The RON. RON. Why are they telling me this? Okay, RON 95. RON 95. You know what is RON? What is RON? Okay, the RON stands for rated octane something. RON stands for fuel. There you see, research octane number. Right? So RON 95 has a rating of 95. That means it's not that pure. RON 97, it has higher octane rating. That means it's more expensive. And then you have RON 100. Right? Guys, I'm sure your family uses 95. I think I mentioned this last week, right? Most of us, normal people, okay, rakyat mahain, we just use 95 lah. Any of you here uses 97? Any? I don't think so lah. Right? There's no need to, unless you drive like a freaking GTR. Right? GTR calls for at least 97. I mean, of course lah, you're driving a twin turbo V6. Are you going to chip out on your fuel? You got 400,000 to buy a car, you got no money to pump petrol, is it? I will just secretly judge you. Like, got money to buy car, no money to put petrol. So that's your octane lah, right? Then you must say, hey sir, why the front four don't follow one? Don't ask me why. The chemists, they say so. So butane, funny enough, you know what is butane? Butane is actually your cooking gas. Butane is your cooking gas. Okay, have you seen those butane bottles before? Have you been to a Korean restaurant? Have you been to a Korean restaurant? If you have been to a Korean restaurant, you eat those mini pot, I'm sure they have this thing there. Right? It's like a mini stove. Let's say you eat sundubu jjigae or your kimchi jjigae. They will put a stove in front of you and then they will put the soup on it. No one eats Korean meal? Do you know what is kimchi jjigae? If it okay, you know what a Korean meal looks like. They have a pot there. So that's your butane. Okay. So guys, this is just to tell you for fun. My point of today is your hydrocarbon has two. You have saturated and unsaturated. Saturated is full. Unsaturated is not full. Okay. So saturated, we call it alkane. Unsaturated, we call it alkene. End of story. So we learn this for what? I don't know. I don't know. This was originally made for chemistry students. Chemistry, they learn, I understand. But you, I also don't know you learn for what. Ask the government. Okay, somehow they think that, oh, you guys are very smart people, okay, so they let you all learn. Okay, no? Okay, so moving on. So this is renewable energy. Read it yourself lah. If one day we run out of fossil fuel, run out of hydrocarbon, what can we use? We can use solar law, wind law, hydroelectric law, biomass law, geothermal law, tidal law, wave law. This was in chapter 3, you know, that environment chapter, the EM ball, you know, the mud ball thing, that chapter, read it yourself, okay? Not important. Which brings me to my next point. Guys, today, my main point is this. Guys, please put a star here. Please put a star here. Every year SPM, every time trial, every midterm exam, for sure you will see them ask about alcohol. This is the most common part of this chapter. Please pay attention, right? If you don't want to focus on alkane, I'm okay, but you must focus on alcohol. Can you see the name is almost the same? Alkane, alkene, alcohol, all LLL one, right? So alcohol is another family. It's another homologous series. All right, so I'm sure you guys know what is alcohol. So how is alcohol produced? You learn this in chapter 1 actually. It's from a type of microorganism. And what is the microorganism called? I said, right, you only focus on that microorganism. What is it called? It's a fungus. I'll give you a hint here. It's a fungus. It's the similar thing we use it to make bread. It was in chapter 1. Guys, what was it? You can buy this from Bread Shop 1. Yes, Gabriel, you got it. Yes, that will be your yeast. Can you know what is yeast? You know what is yeast? In Mandarin, we say 酵母菌, yeast. You need yeast to make alcohol. You need yeast to make bread. Okay, so how is alcohol made? How is alcohol made? Please memorize this equation. You just need glucose. Glucose is sugar. Okay, you just need glucose. You put yeast. Yeast will produce an enzyme called zymase. You want to memorize this? You don't want to memorize this, up to you. Right? So yeast, they will make zymase. And zymase without oxygen, can you see this is no oxygen? I need to cover it so that yeast has no oxygen. When there's no oxygen, this zymase will convert this glucose into something what we call ethanol. What is ethanol? Ethanol is your alcohol and carbon dioxide, right? This process will make ethanol and carbon dioxide. Sir, why can't we write alcohol? Because alcohol is a big family. Like just now, you see, you have methane, ethane, propane, butane, pentane, hexane. Same goes to alcohol. You have methanol, ethanol, propanol, butanol, pentanol, hexanol, and things like that. Only ethanol we use. We will use ethanol. We use ethanol where? In your hand sanitizer, in your alcoholic drink. Guys, fun fact, ethanol is the only alcohol you can drink. Right? The rest of the alcohol, they are mostly toxic. You cannot drink methanol, for example, you will die. Okay, so you need to write ethanol because this is the only alcohol we get, right? So this process, converting glucose into ethanol and carbon dioxide, you actually get gas. You actually get gas when you're making alcohol. Let's say you're making beer, you actually get carbon dioxide, right? This whole thing is what we call fermentation. Fermentation, in BM we call it penyampaian, 发酵. We do the same thing to bread. We ferment bread, we put it into the oven. But in alcohol, we just ferment it and we just let it be and you get alcohol, right? So anything with glucose or starch, you can ferment it and make it any alcohol you want, right? Like, okay, sugar, you know, okay, grapes. What happens when we ferment grapes? What do you get? What do you get? What happens when you ferment grapes? Anyone? The Europeans, they do it. What alcohol do you get? Guys, are you familiar with alcohol? Are you familiar with alcohol? Unless you're a Muslim lah, okay? Or you're just young, you don't like alcohol. I'm sure during Chinese New Year, okay, we will all bring out, your dad and mom will bring out the alcohol. Yes, you get 葡萄酒. We get wine. We get wine. Grape has two types, okay? You have the red grape and a white grape. That's why you have red wine and white wine, right? This is how you get alcohol because you have glucose in the grape, right? And then apples, what do you get? If you ferment apple, you will get something called cider. Cider, you know, Summersby. You know Summersby? Okay, it's made from apple. One of it lah, right? And then anything lah, sugar cane. Okay, what happens when you ferment rice? Asians, we do it, one. Koreans do it. Japanese do it. We Chinese do it too. When you ferment rice, you will get something called, yes, 米酒, rice wine. You know what is rice wine? You know what is rice wine? In Korean, they call it makgeolli. I don't like this. Makgeolli. This is their rice wine. I don't know, it tastes disgusting to me. It's like a milky alcohol. Not really my thing. Okay, it looks like freaking Vitagen, you see? It looks like freaking milk. So that is makgeolli, right? When you ferment rice wine. Okay, but our Chinese rice wine, Chinese rice wine, our Chinese rice wine is a bit different lah. Okay, this is our 白米酒. And you know sake? Japanese sake. This is Japanese rice wine, right? The one that tastes like, you think this tastes like hand sanitizer? Oh, you'll be mistaken, my boy. Have you tried whiskey? That is, it's even more like hand sanitizer. Okay, so you have, okay, what happens? Okay, what about wheat? What about wheat? Not the wheat they smoke, as in gandum, wheat. When you ferment wheat, you will get beer. You will get beer. Right? So it's a cultural thing, lah. Okay, every culture has different glucose, different source of grain, because grain is glucose, different. Why beer? That's the way it is, lor. Right? So different grain will give you different alcohol. That's the way it is. Okay. Like Indians, they will use coconut instead. They will make toddy. You know toddy? Toddy is coconut alcohol, coconut beer, coconut wine, coconut wine, right? I don't like it because I don't like coconut. So it just tastes weird to me. Okay, so anyway, this is how we make alcohol. This is how we make alcohol. Right, so glucose, again, let me repeat, glucose with yeast, you will get ethanol and carbon dioxide. Do not forget this carbon dioxide. In fact, without this carbon dioxide, you cannot make bread. Guys, do you know this is how bread rise? Okay, if you make okay, let's say you have a piece of dough. You know what is dough? When you make bread, you have a piece of dough, right? When you put yeast, yeast is going to make carbon dioxide, and this carbon dioxide is like blowing the bread like a balloon. Okay, then you might say, sir, then inside bread got alcohol? Yes, you have alcohol inside bread. But after you put it into the oven, after you bake the bread, the alcohol is gone. It's evaporated. Right? But when we are making alcohol, this is what we want. Ethanol is what we want. But when we are making bread, carbon dioxide is what we want. So it's a different thing. Okay, so this is fermentation. So you have glucose plus yeast. This thing will produce carbon dioxide. And how do we test carbon dioxide? This was actually Form 3. How do you test carbon dioxide? We will use something called lime water. This is called air kapur, 石灰水, air kapur, lime water. Okay, guys, lime is a stone. You know lime cave? Batu cave is a lime cave. Batu cave is made from limestone. Lime is not limau. Okay, lime water is not limau ice. Okay, so this is your lime water. So when there's carbon dioxide, your lime water will go from clear, as in jernih, bersih, completely clear, to cloudy. Cloudy is keruh. They look dirty. Okay, let me show you. Lime water. All right. So if you have carbon dioxide, your lime water are there will become like this. They will go from clear like water to become dirty like what? Like rice water. Okay. So cloudy. Okay. So this lime water is to prove that carbon dioxide is produced, and we will make alcohol. Okay. And okay, guys, one more thing. Do you guys drink wine? Do you guys drink wine during Chinese New Year? Maybe your parents drink wine. Right, when we talk about alcoholic drink, we'll talk about the percentage. Right, we'll talk about the percentage. Like beer is 6%. Beer is very lame. Beer is only 6%. Right? What about wine? Do you know what is the percentage of wine? Have you taken the bottle and read? What's the percentage of alcohol in wine? Okay, let me show you. Red wine. Okay, red wine. Okay, if you read red wine bottles, usually it won't go far. Okay, red wine usually has like, is it mentioned here? Okay, let's see. Are there? Okay, something like that. Okay, usually wine, you don't really get very high alcohol percentage. It's only like 10, yeah, higher than beer. Okay, 10. The highest I've seen is like 16 or 17, maybe, right? But it's usually like 10 to 12. Okay, it's really low. Wine is really low. You might say, sir, why is it only this low? Why can't yeast make more? Why can't yeast make more ethanol? Right, as you know, ethanol is in your hand sanitizer, right? That means alcohol themselves is an antiseptic. You know what is antiseptic? You learn this in chapter 1. Antiseptic is something that kills bacteria. So guess what happened? As yeast makes more ethanol, the ethanol will end up killing the yeast. They are making something that kills them, kind of like a retardo mode here. Okay, yeast, they are a bit retarded. They make something that kills them. So highest you will go is like 10 to 12, because as you approach like 10, the ethanol is too strong and the yeast will die. You see, retarded one, like the yeast is very stupid. Right, so then if you say whiskey, okay, guys, have you seen whiskey before? Well, I can talk about alcohol all day. Yeah, I'm a very big fan of alcohol. Okay, let's say whiskey. You know whiskey has how many percent? You know whiskey is how many percent? Whiskey is at 40. Can you see the sticker there? Mengandungi 40% alcohol. It's like 40. Then how did they get here? How do they get here? You see, the highest is 10, right? Sir, you say highest is 10 to 12. How can they get 40? This is how, right? They will do something called purification. And I don't like to call it purification because you learn this in Form 2 actually. This is actually what we call distillation. Penyulingan. Remember this equation? Remember this process? Okay, what is distillation? Basically, you take this impure alcohol and you put it here. Let's say this is the 10% alcohol. Okay, 10% alcohol. So what do? You heat it so that it evaporates. It evaporates. When they come into this tube, can you see there's water around the tube? That means inside here is very cold. When hot steam touches cold stuff, what will happen? What will happen? When hot water, hot steam touches cold glass, what do you see on the glass? Again, when you have hot steam touching glass, let's say you shower, you have hot steam, the steam touches your toilet's glass, what do you see? What do you see? Yeah, you cannot see heat, right? What do you see? What do you see on your window? You see water droplets, right? You see water droplets on your cold surface, right? This is what we call condensation. Remember? So this thing will come here and condense, and then it will turn into liquid and drop back down, and this is how you get your pure alcohol. Pure ethanol. This is how we turn 10% to any higher percentage we want. We can use this to make whiskey. We can use this to make tequila. You know, tequila is for like, it's like a Mexican drink. It's really, really bitter. That really tastes like hand sanitizer, right? You can use this to make vodka. You know vodka? Vodka is also 40%. You can use this to make gin. You can use this to make rum. You can use this to make absinthe. Now, all these are strong alcohol, right? Like all these alcohol I've mentioned, vodka, gin, rum, whiskey, even brandy, absinthe, tequila, all these, they're at least 40%. At least 40%. Right? If you are not, you know, an alcohol drinker, you think like, who the hell would drink this thing? It's so bitter. Guys, have you tried beer before? Have you tried beer before? I mean, some of you tried beer, and you'll be thinking like, who the hell drinks this thing? It's so bitter. Right? Guys, that is only 6%. Imagine 60. Imagine 40. So that's why it tastes like hand sanitizer. Okay, so you have two processes here. You have the fermentation itself, and you have the purification, which is to purify this thing. So this is the first equation that the first reaction that you should know. This is the second reaction that you should know too. I mean, this second reaction is kind of what you learned in Form 2 already. Okay, there's a third one. Guys, can you please go to the next page? Can you please go to page 6? There's one more. I'll come back to here later. Right, that's the third one. When you add alcohol to an organic acid, what is an organic acid? Something that is weak, something that is from living thing. Like, what is this ethanoic acid? Ethanoic acid is actually your vinegar. Right? You can actually try this later. You take some hand sanitizer and you mix with your acid here. You will get something called ester. Ester. Not your friend Esther. Again, I'm sure you have a friend called Esther. Right, this is without the H. Right, do you know what is ester? You know what is ester? Ester is the perfume. Ester is a perfume, right? That means, you know, alcohol has a smell, right? When you heat this alcohol and this organic acid, this thing will smell sour because it's vinegar. When you heat these two together, they will start turning into something sweet smelling, like your chewing gum, like your fruit juice, like your perfume, anything that smells nice. Okay, that means they have turned into ester. This is the third reaction that you should know. And this reaction, we have a name for it. We call it esterification. We are esterifying it because ester, when I change something to ester, we call it esterify. I esterify this thing. So the whole thing is called esterification. Okay, can? So this is what we call esterification. And we will usually add a few drops of concentrated sulfuric acid as a catalyst. Guys, do you remember what is a catalyst? You actually learned this last chapter. Do you remember what is a catalyst? It is something that speeds up your reaction. Remember that? Remember that? Like last week when we talked about Haber process, we will use iron fouling as the catalyst. And contact process, we will use that vanadium oxide as our catalyst. You remember that? So in this case, we will use concentrated sulfuric acid as our catalyst. This thing will make this reaction faster. Okay, that's all, right? That's pretty much it. And okay, let's talk about this one. This is something really easy. Okay, so physical properties of alcohol. How is alcohol like physically? Number one, alcohol is colorless. Your hand sanitizer is colorless, right? Liquid at room temperature. Your hand sanitizer is a liquid. Okay, and then it has a distinctive smell. I am sure you know how alcohol smells like, right? If you smell a beer bottle, if you smell a whiskey bottle, and if you smell your hand sanitizer, they kind of smell the same. That's the alcohol smell, right? It has a distinctive smell. That's why, guys, if you have been to a bar, if you have been drinking a lot, even when you talk, even when I sit next to you, I will smell the alcohol in your breath, right? Right? If your dad is a drinker, I am sure after he drinks and he talks to you, you just kind of know he drank, right? Because his breath will smell like alcohol. Guys, this is why you don't drink and drive. It is very easy to tell when you drink and drive because I just need to talk to you. Let's say you go through a roadblock after you have been drinking. Just by talking to you, the police officer will know you have been drinking. And they will ask you to breathe into this thing called a breathalyzer. Is it called breathalyzer? Breathalyzer, yes, this thing. They will ask you to blow into this machine. Okay, they will ask you to blow into this machine. And if your alcohol level is above a certain number, that means you have been driving. All right, guys, please don't drink and drive. It's a very stupid thing to do. Please be responsible, right? If you drive after you drink, you deserve to go to hell. Okay, please don't do that. Okay, but when the police asks you to breathe into this thing, your number will be above, and they will gantung your license for 5 years. That's the not so serious punishment. They gantung your license for 5 years. If it's serious, you kill someone, you accidentally run into someone, then it's jail time, right? It could be like 10, 20 years if you kill someone. Just to be stupid, okay? You know you shouldn't do this, right? I mean, those people who are caught drink driving, they all know it's wrong, but they still do it anyway, right? So you know it's wrong. Okay, so these two we ignore. These two, they're actually in your chemistry, it's not related to you. What about chemical properties? We all know alcohol is very combustible. Alcohol can very easily catch fire. You all know this, right? So please don't put your hand sanitizer in your car. When it's hot enough, the thing will start catching up in flames. This is how you burn your car. You know what is a Molotov cocktail, guys? Do you know what is a Molotov cocktail? Yes, it's an explosive. Right, guys, if let's say Malaysia is in civil war, let's say one day Malaysia is in civil war, you have no money to make a bomb, you don't need any. You just need alcohol and bottle and fire, right? You just put a piece of cloth into the alcohol, light up the fire and you just throw into anyone you want. This is the cheapest bomb you can make. Right? We call this a Molotov cocktail. Okay, so in Ukraine, this is what they do. In Ukraine, this is what they do because Ukraine is fighting the war against Russia, right? So this is what they do. So as you can see, this Molotov cocktail is pretty flammable. Alcohol is very flammable, right? That's why you never, if you buy a bottle of, let's say a big bottle of hand sanitizer, they will put a logo there with the flame logo there. That means it's very flammable. And you know this, just like your petrol. Okay, so that will be it. Before I go to exercise, okay, guys, you have any question? Do you have any question? So my focus today is your alkane and alkene, your saturated and unsaturated hydrocarbon, your fermentation, what happens here, the equation, your distillation, okay, you purify your alcohol, and your esterification, which is to make ester. Guys, let me tell you this, all the fruit juice you buy, all the snacks you buy, okay, from any snacks that you eat, do you think they are so good they use natural flavoring to you? No, it's usually just ester. All that fruit juice, okay, all that chewing gum especially, they will use ester. They are not that kind-hearted and give you real flavoring because it's really expensive. They just use ester. You know vanilla extract? You know vanilla extract? Guys, any of you bake here? Any of you of your moms bake here? You know what is a vanilla extract? This thing is actually made from ester also. Okay, this thing is an ester. Right? You know why? Because real vanilla is freaking expensive. Do you know that? Do you know that? You know how a vanilla plant looks like? Nobody can afford to eat this thing in huge amount. Because this thing is freaking expensive. Vanilla is freaking expensive. Okay? We call this thing the vanilla bean. This thing. This is how they extract vanilla. They will cut this stick open and then they will scrape the vanilla bean. Right? Hey, 3 stick of this, 3 stick will cost you like $50. Okay? And if you make a cake, you need like what? 3 sticks, maybe 6 sticks. You think you are rich enough to put $100 into just a cake? No. That's why we usually will just use vanilla extract. Nobody will use real vanilla unless you shit money. Just like your wasabi lah. Okay, nobody eats real wasabi. It's all just horseradish, right? Anyway, so you guys have any question? Any question? Any question? You guys feel, I feel that you guys are very tired. Is it? You guys can talk, you know this, right? I'm not going to bite you or something. Right? You guys have any question? No? No? Very tired. Must be the weather lah, right? Must be the weather. You know why are you guys so tired? You know why are you guys so tired? You know why you guys so tired? Number 1 is the heat. Number 2, you guys had too much of holiday. Right? You guys have been having holidays after holidays. Now, when everything restored to normal, you can't take it. I know, right? I know. Imagine the amount of holidays you guys have been getting. It's ridiculous. So it doesn't feel good when you go back to school, right? You know what my student told me yesterday? Sir, I wish that our Malaysia temperature can go to 30, 38. I was like, why? Oh, because government say 38 degrees, school has to stop malu betul lah, say this kind of thing, right? Or they tell me, oh, sir, I heard in August the haze is coming back. You know this, right? Because they say the heat spell it is so hot right now. They say by July or August, there's a big chance that haze will return. Then my students, you know them, I'm sure you guys are part of them. Yes, haze. Go and die lah, you want our Malaysian air to smell like shit, right? We did not do any exercise last week, huh? Okay, let's do some exercise today. Let's go to question 2, shall we? Page 14. Too much tido, no wonder lah. Okay, so page 2, question 2. Guys, I'm just going to straight away give you the answer here. Okay, as long as you know what is X, Y, Z, you will do. Right, so you see, this is carbon dioxide in the atmosphere. We have a few processes to make carbon dioxide. That is respiration. Okay, what else? When you see fossil fuel, what do you do with the fossil fuel? You burn it. So X is combustion. Pembakaran. Right, that's the second process. And what else? What else is Y? Organic compound in your plant, what does it do? They also do respiration. Plants will do respiration too at night. Okay, respirasi. Because you have decay here already. You see, decomposer, respiration in decomposer is decay. Perebutan. Like I said, you have 3 processes of making carbon dioxide. Combustion, burning, respiration, and decay. And how do you take away carbon dioxide? How do you remove carbon dioxide from the air? There's only one process, and it's done by plants. That would be your photosynthesis. Write this yourself lah. Write this yourself. I'm not gonna write the full answer. And the rest of the question, you can do it yourself. I'm just telling you, I'm just giving you a sort of like a quick reminder how this carbon cycle works. Okay, so let's look at number 4. What are hydrocarbons? Okay, very good question. Hydrocarbons, they are compounds that contain hydrogen and carbon. Sebatian yang mengandungi hydrogen dan carbon. Carbon compound is a compound that contains carbon. Hydrocarbon is a compound that contains hydrogen and carbon. No shit, Sherlock, am I right? So okay, your exam is not gonna be this easy lah. This is just like a warm-up question. Okay, so what are the natural sources of hydrocarbon? Where can you find hydrocarbon naturally? Where can you find hydrocarbon naturally? There's 3 sources, and they are your 3 fossil fuels. What are your 3 fossil fuels, guys? What are your 3 fossil fuels? Hey, don't leave me hanging, I'm talking alone myself, I'm very tired. What are the 3 fossil fuels, guys? What are the 3 fossil fuels? Hello? Hello? What are the 3 fossil fuels? Hey, 6 brains here. We have 7 people here. Okay, I have a brain, then the rest 6 of you. Okay, 6 of your brains. Okay, what's your fossil fuel? Guys, what is a fossil fuel? You have 3 types of fossil fuel. Okay, you have your petroleum. Yes, coal, thank you. And you have your natural gas. Your petroleum, arang batu, dan gas asli. Yes, thank you. These are the 3 types of fossil fuel again. These are the 3 types of fossil fuel. Okay. Next, C. How are the natural sources of hydrocarbon formed? How do you make hydrocarbon? How is petroleum and natural gas formed? Because they're in a group, they're in the same group, right? How is coal formed? Okay, so they are from dead organisms millions of years ago. Okay, organisma mati beberapa juta tahun dahulu. All right, so what happens next? Under years and years of pressure and heat. Tekanan dan haba. Like I said, this is last week. I said this last week, right? After they die, they sink to the bottom. They are pressed by pressure and they are heated by the lava. They will turn into petroleum and natural gas and coal. Okay, so name the types of hydrocarbon. What are the two types we have learned just now, guys? What are the two types? The full and the not full. We call it saturated and unsaturated. Tepu dan tak tepu. Hiya, so easy lah. So easy lah. Okay, what about question 5? Okay, let's do one more. Okay, you know it's gasoline, guys? Do you know what is gasoline? Any of you watch American drama? This is how they say petrol. Right? That's why the Americans, they say, oh, I need to go to the gas station. The first time I hear this, I was like, what the fuck is a gas station? Oh, it's a petrol station, you mean? Goodness me. Gas station. I thought you buy gas there. Right, so what is X, Y, and Z? Okay, so your X should be the cleanest among these three. X is the cleanest, Z is the dirtiest. Right, so who is the cleanest here? That will be your kerosene, followed by diesel, followed by fuel oil. You might say, hey, sir, I thought after petrol is naphtha. They didn't follow sequence here. Because there's no naphtha here, you see? There's no naphtha here. There's no naphtha here. They straight away jump to kerosene, diesel, and fuel. There's no lubricating oil here also. They are skipping. So I want you to know the sequence, that's why. Okay, so this process is called fractional distillation. Okay, penyulingan berperingkat. Just like the distillation you do to alcohol just now, but I do it in many layers. Fractional, you know, it's a fraction. That's a fraction. I do fractional distillation. Okay, guys, before I go, please go home, right? Please go home, and try question 6, the alkene. Try question 9, alcohol, and try question 12, which is your ester. The 3 things we learned today: alkene, alcohol, and ester. The 3 things you learned today. I'm not asking for much. I'm asking for you to try this, right? I mean, I won't check your homework lah, but the more you do, the better you become. Okay, you want to remember what you learned today? The best way is by doing exercise. Okay, any question? Any question you might have? Any? Okay, silence. I will take it as a no. I'll take it as a no. Right, so thanks for coming, guys. I will see you the same time next Wednesday. Okay, have a good one. Good Wednesday. I will see you soon. Right, so take care, guys. See you. Have a good one. Bye-bye.